Thank you, everybody. And Simon, thank you so much for inviting me to PHP Cambridge to come and talk about how to make digital technology more sustainable. It's a topic I'm really passionate about. It's a topic I spend a lot of time, both professionally and outside of work, working on, learning about and sharing. So it's a real honor and a privilege to be here with all of you tonight. I'm assuming it's tonight for most of you, because I know some of you aren't joining from the UK perhaps, but it's a real privilege to be with you at this moment and to be talking to you about this. So a little bit about me. I sort of talked a little bit about my background already. My day job is I work as a freelancer, and I work with WordPress, and I have done for 7 years as a freelance developer. I'm also transitioning into a role as a sustainable web consultant, which sounds very fancy. Still not entirely sure what that means, but basically talking about this stuff with people, tonight's content. I'm co-founder of a meetup called Green Tech Southwest, which I mentioned as well. It's based in the southwest of England, but if you were here for the preliminary chat, everybody's welcome. We have a really thriving online attendeeship, and we cover lots of interesting stuff. So if you like the kind of things we're talking about tonight, you'd be more than welcome to come and join Green Tech Southwest. I'm also just completing a fellowship with the Green Web Foundation and picking up some work with them as operational manager. And I'll talk a little bit about the Green Web Foundation as I go into the talk this evening. And I also do a lot of work with a really awesome community called climateaction.tech. If anybody is with knows about climateaction.tech, do let me know in the chat, which I can see, by the way, and I can keep kind of tabs on, and I can respond to you as I'm doing the talk tonight. So don't be afraid to kind of chat at me or chat to one another as I'm talking. So with Action Tech, I founded a campaign called Let's Green the Web, which was all about raising awareness about the fact that websites create a carbon emission, which I'll talk a bit about later. So on to tonight's talk then. What am I going to cover? So I'm going to start by talking about what sustainability is. Some of you may have come here with different ideas, and some of you, well, anyway, let's just all get on the same page with that term of sustainability. I'm going to talk about areas where we can focus our efforts on. So if we understand what sustainability is in a digital tech context, then let's talk about some ways that we can focus our efforts to make things different, make things better. And I'll also sort of pepper throughout the talk all sorts of approaches that you might find useful to investigate. I think when you define what something is, it's helpful to define what it isn't. So what this talk isn't is hating on digital tech, WordPress, PHP, or the internet. I mean, that would be kind of a little bit crazy given my job. I am a fan of digital tech, of WordPress, of the internet, of all of these things, and I very much love the possibilities and solutions that they bring. So this is more a talk about using them wisely and valuing these things more highly than we do at the moment. And the other thing I think it's really important to say, I mean, I'm aiming to talk for maybe 30 minutes, 35 tops, hopefully with a little bit of commentary from you guys as we go. This is a huge topic. So this is definitely not a comprehensive masterclass on the whole topic. This is an emerging field. There's lots for us to learn. So really my aim this evening is to give you some ideas and to give you some food for thought, and maybe to get some conversations going, or to get you thinking about things in a way that you haven't thought before. So do give some practical actions, but also, I really want to sort of stimulate thought and stimulate consideration of the topic. Because essentially knowledge is power, right? So if you are knowledgeable and you know what the dangers are and the problems are, you can do something about it. So that's my little intro. I'm just the comments, fantastic. Okay, so how do we define sustainability? So let's start at this point. What do we mean when we talk about this topic of sustainability? So this is the definition that I typically use. the short, snappy version. So the definition, it says, meeting the needs of the present without compromising the ability of future generations to meet their needs. So it's very much thinking about sorting ourselves out today without stopping progress, without stopping other people in the future meeting their basic needs. And this definition has been around a while. It's from something called the Brundtland Report, which, if memory serves, was written in 1987. So it's been around some time. So that's the one-liner. And then within that report, it talks about 3 key pillars. Now, what's fascinating and mind-bending and sometimes incredibly frustrating about the topic of sustainability is that these 3 pillars are very, very interwoven. So you can talk about one pillar, but you can't really talk about that without touching on the other things. And you'll kind of see that throughout this evening's talk. So the 3 pillars that are defined, the first one is environmental. And this is what a lot of people think sustainability is. But that's just one of the pillars. One of the other key pillars around sustainability is economic and governance. So basically decision-making power. And the third pillar is social. So it's how we as humans behave and interact. And it's these 3 things that come together that actually give a truer, more holistic view of sustainability. So the first thing I really want to get across is that sustainability is way more than just carbon emissions. And a lot of people come to sustainability because they've heard about climate change and they're worried about the amount of carbon emissions that we as humanity are producing. And it is definitely a problem. But true sustainability is looking beyond a carbon emissions tunnel vision and looking into a wider set of considerations. And I will talk through some of those this evening and attempt to do my best to put those into a technological context for you. So that's the first thing I'd like you to take away from this evening. Sustainability does not equal decarbonisation. It's more than that. Okay, so let's get into the environmental stuff. I tend to think of the environmental stuff as natural resources. I find that a bit of an easier way of viewing it. So digital tech uses lots and lots of natural resources, some of which you may be aware of, some of which you may not have considered before. So the one that most people are aware of is energy production or electricity production. And digital tech gobbles up quite a lot of energy. And I'll give you some stats on more specifically on how much in a sec. And energy production can come from burning of fossil fuels, which we know is bad. It can come from renewable sources such as sun and wind, which produces a lot less damage or impact, but still some impact. And nuclear is another option. There are, of course, a few other options in between, but those are the main ones. Other kinds of natural resources that digital tech use. So the physical hardware, the stuff that we're actually running digital tech on, has to be built from something. And increasingly, we are seeing rare raw minerals such as cobalt and lithium being used in batteries and in mobile phones. And those things have to be mined. And those mining practices are actually very extractive and damaging. They're not just damaging to the natural environment around them, but they're damaging to the communities as well, where the resources are being taken from. So there's that consideration. And then there's data centers as well. And I often think whoever came up with the term cloud computing and managed to convince us all that data centers float up in the air, I mean, they probably deserve some sort of marketing medal, really, don't they? But the reality is, no, these data centers very much live on the ground. They require quite a lot of land and also an increasing amount of water to keep them cool. And of course, energy to run as well. So digital tech does have a very real impact on the Earth's natural resources. And of course, the issue really is that the misuse of these resources leads to interconnected ecological problems. So what you have in front of you, I hope you can see the words, are 9 ecological factors. And these are defined by something called the Stockholm Resilience Centre. So they're generic, they're a wide view of how the world works. It's not just related to tech. And can you see in those sort of, I don't know, like just gone 12 o'clock position, One of those points is climate change. There are 8 other points for us to consider. So again, I just sort of want to hammer home this point that sustainability is a much wider set of problems than climate change and carbon emission. There's also things to think about like biodiversity loss, freshwater withdrawals, chemical pollution, etc. I don't know if anybody's come across the Stockholm Resilience Centre before, but if you want to learn more about sustainability and want to learn more about how the planet works, it's a really interesting resource. JJ, I've just seen your comment there. Yes, I don't think I'm going to shatter your self-concept, but I may present some other alternatives. Okay, so yeah, and Ruth, you're absolutely right. Hardware also uses many other elements and minerals, including PVC, ABS, gallium, arsenic, molybdenum, gold, copper, silver, tin. Yes, you're absolutely right. We don't often appreciate just how much goes into these things. I'll talk a little bit more on that in a tick. So tech does have a real impact on the earth. Now, what I'm going to do is focus in on one particular subject that I hope all of us can relate to, and that is the topic that most people will start thinking about first when they start thinking about digital sustainability, and that is energy and electricity production. And so I've mentioned that already. So it's a great starting point. So if you're new to thinking about this, wonderful, great place to start. There's nothing wrong with thinking about where your electricity comes from. But consider it as entering into one of those 9 planetary boundaries that I showed you previously, the climate change one. So you're starting on a part, and there's a bigger journey to go round. Oh, I should mention here on this slide, I'm using a shorthand, a GHG. Some of you may be aware of what that stands for. It stands for greenhouse gas emissions. So carbon dioxide is the most commonly talked about greenhouse gas. But there are a number of others which are also quite damaging. But just to keep things simple, we'll just talk about carbon dioxide generally. So let's talk about how digital services cause greenhouse gas emissions, or more specifically carbon emissions. First up, let's have a stat. It's estimated that ICT, which stands for Information Communications Technology, you could just basically think of that as digital, creates between 2.1 and 3.9 of global greenhouse gas emissions. So it's quite significant for something that we think floats around in the cloud, or maybe we haven't considered before. Quite a lot. And to put that into context, we can also think about that number as if ICT was a country, it would be the 7th biggest polluter. So I think that really helps to hammer home what that range actually equates to. And it is actually more polluting than aviation. You may have heard these 2 facts used before when talking about the digital impact, when talking about the impact of digital tech. I think it's useful to talk about tech as being bigger than aviation, the pollution caused. But I just want to sort of put a bit of a qualifier around that and say, please consider how many people in the world have access to flying. It's about 20% versus how many people have access to the internet. It's about 60%. So I sometimes feel a little uncomfortable with using that as a direct comparison, but it is often used. This is a wonderful diagram from Our World in Data. I don't know if anyone's come across Our World in Data before. It's a fantastic resource. I just thought I'd put this up here just to kind of give you an idea of globally, sector by sector, where greenhouse gas emissions come from. And you can see there that energy really is the biggest emitter. And the bottom right, so what would that be, sort of like between 4 and 5, 4:30? You can see aviation down there. ICT isn't listed as its own thing because it stretches across so many different sectors. But that's a nice diagram to help put into context where all of the world's greenhouse gas emissions come from. So I mentioned to you that ICT, or digital tech, is responsible for a significant amount of carbon emissions. And the thing that I think is useful to be aware of is that demand or usage is massively on the up. So this is a really cool diagram or a cool set of data that came from the IEA, the International Energy Association. And it shows how how much data flies around the internet. So it's annual global IP traffic. And to keep it simple, let's just say the internet came about in 1987. I know it's like, you can argue a little bit either way. And it was responsible roughly for 2 terabytes of information flying around. By 2017, it was responsible for 1.1 zettabyte. If you're wondering, zettabytes, it's got a lot of zeros on the end, 21 zeros on the end to be precise. And it's predicted to explode within the next 5 years, so from 2017 to now, to 4.8 zettabytes. So we are doing a lot more online. And that's only 60% of the world that's still using the internet. So, it'd be nice for everybody to have equal access to the internet and to digital tech. So that's just putting some things in context. I hope that's making sense so far. So do feel free to ask questions or share your thoughts. I'm going to move on to giving you some ideas about how you can actually calculate digital CO2 emissions. There's some really useful tools and resources out there to help you. Before I point you in the direction of the tools, I will just give you a brief overview of how you can calculate these emissions and what the key considerations are. So the foremost key consideration is to think about what device is actually being used to access a website. And I'm just going to talk about websites. I'm sure many of you are working on other things apart from public websites, but I think public websites are a nice, easy one to talk through. So the first factor is what device is being used to actually view the final web page on. Another key consideration is where does your energy come from to power that device, but also to power the data centers as well that are holding and processing the data. And the third very key consideration is how much data is actually being transferred or sent to the user. And it's that last part that you use in the calculations. So we can actually figure out how much data is being sent and then equate that to carbon emissions. And I think I have a slide coming up that explains that to you. So just going to talk through devices. So the general model that's used is a model called CO2.js, and it's from the Green Web Foundation. And that uses a model that says 52% of the energy consumed by someone viewing a web page actually comes from the device that they're using to view that page with. So it's useful to have a think about devices, have a think about large screens versus mobiles, and appreciate that there is a knock-on effect to carbon emissions and therefore sustainability through the use of the device. So manufacturing costs the earth. We've talked a little bit about that already, but surprisingly, the majority of total pollution from digital devices actually comes from manufacture. Smartphones are the worst. I think that they're sort of somewhere around 80 or even 90%. And we've talked about the use of rare raw materials. This is a really nice diagram. This comes from a paper written in 2018. And the black bars talk about the embodied carbon. So basically how much carbon was emitted in manufacturing said device. And the yellow talks about the projected energy consumption of that device over its lifetime. So TVs, assuming you keep a TV for 7 years, actually it's going to consume a lot more energy over its life than when it was made. But look at smartphones over on the right. Smartphones, the majority of the pollution, the carbon, actually is locked into just owning the device, not using it, just owning it. So one thing I would really strongly encourage you to do, both as a citizen, as an individual, but also someone working in tech, is to reframe how you value your device and reframe how your users should value their device. They're really precious, and they shouldn't be viewed as something disposable that we upgrade to the latest model every couple of years. So specifically, when we're creating tech, it would be great for us to be able to support older devices, slower devices, and not feel the need to keep adding features that mean we need more powerful devices all the time. It's often not needed anyway. If we, this isn't a talk about UX, but UX thinking is often simplicity is best. So let's reframe how you value your devices. A few questions. Do you really need to upgrade to the latest device? Can you repair or upgrade a broken device? I don't know if you've heard about planned obsolescence. I'm not going to get into it now because time is marching on. But if you're interested in that kind of thing, do look up the right to repair movement. Can you get refurbed or second-hand devices? And can you buy ethically made devices? We're starting to see more ethically made devices. So I don't know if anyone here's got a Fairphone or ever heard of a Fairphone. They're a good example of electronics being made in a sustainable and circular fashion. Okay, so let's move on to e-waste very briefly. So we've talked about the manufacture of devices. We also need to think about the disposal of these digital tech devices. In 2019, 50 million tons of e-waste was being produced each year. It's an insane amount of stuff we're throwing away. I don't know about you, but I think most of us have probably got a drawer of cables somewhere or a drawer of old phones or old devices. And we're still throwing away 50 million tons of e-waste. And the UN estimates that maybe in 2016, only 20% of that e-waste is actually recycled. So it's often going, well, to places that I'll show you in the next slide. The EU Parliament estimates that obsolete cables, just cables, generated more than 51,000 tons of e-waste per year. So it's a lot of stuff we're just, using and then throwing away. And the question we have to ask ourselves is, where does our e-waste end up and who pays? So this is a photo of a well-known e-waste recycling facility in Agbogbloshie in Ghana. It's a really interesting case study. On the surface of it, you might think that this is a disaster, and in many ways for the natural environment it is. But then there's also this really interesting set of jobs and opportunities and culture that has grown up around this site that really encourages reuse, remanufacturing, and refurbing of devices as well. So it's a very complicated story. But this photo is of a young man who's burning e-waste in order to extract copper from it. It's very dangerous and not good for the natural environment either. So there's a lot of interesting issues to think about with e-waste. So I'm going to move on. We talked a bit about devices. Let's talk a little bit about energy. Where does your energy come from? So in 2019, 63% of the world's electricity still came from fossil fuels. And whilst the share of renewables is growing, so is the overall amount of energy that we are producing and consuming. So it's a good story to see more renewables, but it's still, if we're going to sort out climate change, we literally have to stop burning fossil fuels yesterday. We cannot be putting more of these into the air. So the fact that 63% or thereabouts is still coming from fossil fuels is not a good story. So we need to reduce the amount of fossil fuels, but it is worth saying that renewable energy also isn't a panacea. So producing renewable energy still requires natural resources, but it is less than fossil fuels and less damaging. And what we should be doing is actually looking to reduce the overall amount of energy needed by addressing consumption and efficiency, and then ensure that the energy needed has the lowest impact. So some of you maybe are aware that you can switch your data centers to running on renewable energy. And that's a really specific and proactive action that you can take that makes a big difference. And this is a stat from an Ericsson report that says the estimated reduction of the ICT sector's carbon footprint would be 80% if all electricity consumed came from renewable energy sources. So really strong takeaways: switch your hosting to one that runs on renewables, switch your home office if you have one, and your workplace to running on renewable energy does make a difference. And the Green Web Foundation has a fantastic resource and a fantastic data set for understanding what energy sources hosts and servers are using. So you can go on their website, put in any URL and get a sense of where that hosting what energy sources that hosting is running on. If you are a bit more into sort of the geeky side of a data center, so I'm just going to move my heater away because it's getting a bit hot. You might also want to think about PUE, which stands for Power Usage Effectiveness, which basically determines how energy efficient data centers are. And I believe if a data center has a PUE of 1.2, then it's considered very efficient. So that is another stat to think about. Maybe some of you are aware of it already. I'd love to know if you're all still with me, and if you have any thoughts on switching your hosting to renewables, if you have any questions around that, whether you know of any data centers with good PUE numbers, how that's achieved. I'd love to hear from you. I know that I'm doing a lot of talking, so let's move on. So I mentioned to you already that how much data you're sending is a really key consideration. Data transfer equates to emissions created. Simon, thank you. I've always wondered how easy it is to assess green web hosts. Yes, good question. I'm going to come to that at the end. The short answer is not easy because there's a lot of greenwashing around. And some of that greenwashing is intentional and some of it is perhaps people just not knowing better. So there's a lot of green hosting companies that will say they're green because they buy offsets. And I've views on that. So it's not straightforward to assess green web hosts. Yes, and JJ mentioned Green Geeks. I think Green Geeks might do that. I'm not sure if that's right. I think they buy offsets. Yeah, we'll talk about offsets in a little while. I'm going to keep going, but I'm really happy to sort of get into a bit of a conversation and unpick that a little bit more if anybody's interested in unpicking it a bit more. Okay, so basically, a lot of people may have come along to this talk expecting me to talk for half an hour about performance and optimization, because that's what a lot of people see as making digital tech more sustainable. It's about reducing the amount of stuff loading. And it is definitely an important thing because the more data that's transferred, the more electricity that's used, and the more carbon we emit. So there's a direct relationship between the amount of data and the amount of emissions being created. So we definitely do want to care a lot about performance and optimization. And the Sustainable Web Design website has a great write-up about this. I've also added a load of useful measurement tools to the end of this slide pack, a few books that I recommend for you to have a look at as well. So I'm going to just very quickly rattle through some examples or some ideas about how you can reduce data demand. So you can reduce data demand by only creating and storing data you actually need. So backups can take a huge amount of energy, have to be stored somewhere, and are often stored in data centers which give you instant access to the data. So you can reduce those backups or even put them into sort of long-term storage, which would reduce the amount of energy required. So reduce backups, archives, and logs. Analytics data is another one. There's a really interesting fact that 90% of the analytics data collected is never even looked at. It's called dark data. So I think I'm always sort of trying to encourage my clients to use less analytics or switch analytics on for a short time, collect the data and then turn it off again if they need to use things like Hotjar or more sophisticated data analytics. Remove plugins, third-party services and things like that that you don't need but are just running in the background. A big one to focus on with reducing data transfer is transferring media content on demand. So avoid auto-playing videos. They are a sustainable developer's worst nightmare. And lazy load images and videos. Images and media require an awful lot of attention. Thank you, Ruth. It's nice to hear from you. I'm enjoying your comments actually as we're going. You said I agree. 50% of my analytics is never needed. I just don't know which 50%. Yeah, that's often an issue, isn't it? So coming back to reducing data transfer, paying attention to images. Images often, if you don't have video, it'll be images that will be responsible for the most data transfer on a page, on the average web page. So use the right format for the right image type. I'm forever educating clients that JPEGs are really the best things for photos and not PNGs. You can do a lot of cool stuff to compress JPEGs. You can reduce their quality right down, and your eye can't tell the difference, but you can massively reduce the file size. Display images of the right dimensions, and we have some fantastic HTML tags like image source set or the picture tag, which you can use to serve images responsively. Updating to the latest version of PHP and WordPress. I heard a talk by Derek, I'm going to murder his surname. I'm really sorry, Derek Rothens. I'm sure a lot of you will know Derek. He was talking about the performance improvements of PHP 7 over PHP 5. And it was enormous, like absolutely massive. But in the WordPress community, we've still got loads of people using PHP 5.6. So updating to the latest version can help reduce data transfer and be more efficient, and disabling unneeded code. So this is a great book, Sustainable Web Design by Tom Greenwood. If you really want to get into the nuts and bolts of really sustainable performance and optimization, that's a good one. Ruth is saying the WebP format is supposedly better compression than JPEG while retaining higher quality. All current browsers have supported WebP for some time. That is very true. I still think there's a few issues with WebP format. I do tend to enable it, and it is a good one. There's been a lot of discussion in the WordPress community about enabling the WebP format by default at the moment. They haven't gone ahead with it because they want to ensure more backwards compatibility. It's always that trade-off. I'm happy to talk more about WebP format. Okay, so just conscious of time, I've sort of been talking for about 33 minutes, so I'll rattle through these last few bits. So I want to talk to you a little bit about something called Jevons paradox. I don't know if anyone here has heard about Jevons paradox, but Jevons paradox says that making things more efficient doesn't always decrease consumption. So you might think that making things more efficient will mean that fewer resources will be used because it's running more efficiently. But actually, what tends to happen is usage is increased because the barriers are reduced. So what that tells us is if we are trying to make digital tech more sustainable, we can't just focus on performance and optimization. It's not actually going to make a big difference in the long term. It will make a short-term difference to the users using your service today, which is awesome. And that is a reason in itself to do it. But if we want to make a big impact on climate change, for example, we need to ask some bigger questions. And we need to ask some tricky questions. We need to start asking questions around economics and governance. And I'm just going to rattle off a few questions, the kinds of things that we as a tech community need to be more comfortable with talking about. And some of it is political. And I know within the tech industry, some people really don't like talking about politics. And there's a definite line of thinking that tech and politics don't belong together. I don't think you can extract one from the other personally. So anyway, some of the questions that we might need to be asking ourselves is, what do we value? As a tech industry, as a society, what do we value? Endless growth for shareholders? As a tech industry, do we value going fast and breaking things? I'm not a fan of that phrase. I'll just come out and say it. I think it's a sort of anti-sustainability phrase, that one. As consumers, do we value immediate gratification? As citizens, perhaps doing what we want when we want? We also need to ask ourselves, who holds the decision-making power? Within the tech community, we often hear about big tech dominating our space. And who within big tech holds the decision-making power? Is it the people that we want to have the decision-making power? Shareholders, for example, or local communities, or the government, or consumers? There's a lot of questions to ask. I'm going to leave it there on the economics and governance stuff because it's an enormous topic, and I've been doing loads of work on this in my fellowship. I don't know if any of you have come across Doughnut economics, but if you are looking for a very inspiring and accessible way of understanding this topic of economics, I cannot recommend Doughnut economics highly enough. And I'm working on something called doingthedoughnut.tech, which isn't ready for release yet, but is taking the Doughnut economics concepts and applying them to tech in a very specific way. If you don't fancy the book, you can also find a lot of the resources on the Doughnut Economics Action Lab. And the last pillar in our sustainability is social change. And again, there's a few questions that I think as tech makers, we need to ask ourselves if we are going to make a difference on sustainability. And the question we have to ask ourselves is, what do we create tech for? The short answer is we create tech to be an accelerator of solutions. And the question is, but which solutions are we choosing to accelerate through the use of our skills? Within the tech sector, we have a lot of power to accelerate things. And for me, it comes down to, well, what are we accelerating and for who? Who benefits from the solutions that we create? Who stands to lose out? Whose needs are we ignoring? Who has the decision-making power? And I've talked a lot about decision-making power because it's quite important when it comes to sustainability. And who feels the burdens of our decisions? Some of you may have heard about climate justice before. Maybe you've heard the phrase that climate justice equals social justice. We can't ignore social inequalities if we are wanting to make things more sustainable. So we have to also confront tackling social injustice. And there is a lot of social injustice that happens through the use of tech and the creation of tech. And so this idea of climate justice equals social justice is a cool concept. And it's difficult doing climate justice because it's fundamentally difficult because it requires us to think beyond our current paradigms. And something I love about the Doughnut economics way of thinking is that it really seeks to move us away from current paradigms. And this is where the phrase system change, not climate change comes from. Okay, so this is something I've been working on recently. I suspect that some of you perhaps came to this talk thinking that I would talk about the things on the left a little more than I have. So a lot of people think building a sustainable internet, again, I'm using a lot of these terms interchangeably, a sustainable digital something, means efficient tech, renewable energy, and buying offsets. But actually, it's far more complicated than that. It involves a lot of social movements, and it involves a lot of systemic and political change in order to do that. So, for example, some of the things I've listed on the right are diverse workforces, regenerative business models, open source, accessible tech, etc. So anything where you might think tech for good, that's probably going to come into the frame of sustainability in the digital tech sector. So summing up, digital tech, or making digital tech more sustainable, is not just a tool or code problem. It actually requires us to human better. And I'm sorry if that phrase grates, I'm struggling to find a better one. What I'm trying to say here is that digital tech requires us to think about society and how we behave and act as humans, as well as how we behave and interact as coders. And there's loads of co-benefits to doing all of this stuff. We can reduce natural resource use. We can improve accessibility and UX experience. We can improve performance and speed. And actually, doing all of this stuff can make us more fulfilled humans and do more social good. So, thank you. 40 minutes, sorry, I talked for slightly longer than I was hoping to. I hope you'll forgive me, and I hope some of you are still there. I think Ruth and JJ are definitely still there and have been sort of commenting throughout. If any of you are on Twitter, you can catch me at hanopcan, and if my tweet deck worked, the slides should have been published already. And I'm definitely up for questions and conversation. And just to give you a flavour of some of the things at the end of the slide pack, I've put a load of useful tools, so ways that you can measure stuff, and a whole bunch of other kinds of resources to go and dive into and go and start your journey on. There's lots and lots of stuff to get into.